This is a video for the final review in my Calculus 1 class. Let's take a look at the following example. Find the point on xy equals 8 that is closest to the ordered pair 3, 0. Note, x and y must be positive, and if we draw a picture of this hyperbola here, you will see why that has to be the case. Now, the distance between 3, 0 and the point xy is given by d equals the square root of x minus 3 squared plus y minus 0 squared. Now, if xy lies on xy equals 8, then d equals the square root of x minus 3 squared plus 8 over x quantity squared. 8 squared is 64, right? So we can say that d is the square root of x minus 3 squared plus 64 over x squared. Okay, so a couple of comments here. xy equals 8 tells me how x and y are related. So this is my constraint here. And remember, we're trying to make the distance from the point xy to 3, 0 be a minimum. So in other words, we're trying to find the point on the graph where the distance between that point and 3, 0 is minimized. Now, instead of minimizing the distance, we minimize the square of the distance. So d squared, which we'll call f of x, is equal to x minus 3 squared plus 64 over x squared. If I take the derivative, we get f prime of x is equal to 2 times x minus 3 minus 128 over x cubed. Set f prime of x equal to 0. And so we get 2x minus 6 minus 128 over x cubed equal to 0. And what I want to do is I want to multiply both sides by x cubed to clear the fraction. So that's what I'm doing on this bottom line here. So when I do that, I get 2x to the 4th minus 6x cubed minus 128 equals 0. And we're going to divide out everything by 2. And we get x to the 4th minus 3x cubed minus 64 equals 0. Now, x equal 4 is a solution to x to the 4th minus 3x cubed minus 64 equals 0. And I did that by the rational root theorem. So from here, I use synthetic division to factor this left side out even further. So when I do that, I end up with x minus 4 times x cubed plus x squared plus x plus 16 equals 0. And so x equal 4 is the only positive solution, right? Because if we plug in a positive value for x in this other factor, x cubed plus x squared plus x plus 16, right? There's no way you're going to get 0 back. And so x equal 4 is the only positive value that will work for this equation here. And so I apply the first derivative test down below, and I have my interval from 0 to 4 and my interval from 4 to infinity. I test x equal 1 and x equal 5, respectively, in each of the intervals. Now, where am I plugging this in? Let's go back. I'm plugging x equal 1 in this equation here. All right? And I plugged in x equal 5, incidentally. And you guys have a calculator, right? That's fine. F prime of 1 is less than 0, and so it's decreasing. The function is decreasing on the interval 0 to 4. f prime of 5 is greater than 0, so the function is increasing on the interval 4 to infinity. Okay? Now, if the function's going from decreasing to increasing, we're going to have a minimum. And so f has a minimum at x equal 4. And remember, our constraint is xy equals 8. And so over here, I'm going to replace x with 4 and solve for y. When I solve for y, I get y equal 2. Okay? And the ordered pair 4, 2 will produce that minimum distance. And if we want the minimum distance, right, we can say d is the square root of 4 minus 3 squared plus 2 minus 0 squared. So this is the square root of 1 squared plus 2 squared, which is the square root of 5. So that's actually the minimum distance. So again, the distance is a minimum. At the point for 2. And that'll do it for this video. This is an optimization problem. Thank you.